Everybody, in this video, we're going to be talking about how to solve percent problems with 100 grids. So as a reminder, a percent is a standardized ratio that always has a denominator of 100, and there's three types of percentage word problems that you can have. You can have a missing part, a missing whole, or a missing percent. And there's lots of different ways that you can solve percent problems. And in this video, we're going to specifically be talking about how you can use a 100 grid, which is the two-dimensional model for percentages, to solve problems like this. So before we jump into some example problems, I want to cover a foundational concept that you should make sure your students understand before you start using 100 grids. And that concept is what happens when you divide by 100. And so the idea of dividing by 100 can kind of be thought of as two steps of dividing by 10. Because if I have a number like 246, which I've modeled with these blocks here, if I wanted to divide it into 100 equal sized groups, I could think about it as first taking, say, like one of these hundreds and splitting it up into 10 equal sized groups, and then taking those and splitting those into 10 equal sized groups. And you can see that that would give you 100 equal sized groups where each group would have one unit block in it. And if you cut the second 100 into 10 equal, or excuse me, 100 equal sized groups, you would get another unit block. And if you were to take a 10 block and split it up into 10 equal sized groups, and then take each of those and split those up into 10 equal sized groups, then you would get a tenth from each one of these. So you'd get a tenth from this, and a tenth from this, and a tenth from this, and a tenth from this. And if you were to split each of these ones into 100 equal sized groups, you would get hundredth from each one, because if you split it up into 10 equal sized groups and then split those up into 10 equal sized groups, you're going to get 100th from each one of those one blocks. And so 246 divided by 100 equals 2 whole units, 4 tenths, and in this case, it would be 6 hundredths, because you're going to get 100th from each of those yellow blocks. And again, you would probably want to do this with blocks of the same color, so you can do the whole color coding thing. But my applet didn't let me change the colors. And so notice that when I divided by 100, all of the place values shifted to the right 2 units, because the 200s are now 2 units. The 4 tens are now 4 tenths, and the 6 units are now 6 hundredths. And so anytime you divide by 100, you can do a shortcut and basically just move the decimal over 2 spaces. And this is true even if you have a number like, say, 87 divided by 100. You could just move the decimal over twice, because when you have each of the 8 tens split up into 100 pieces, each of those will be a tenth. So you'll have 8 tenths. And then each of the 7 ones split up into 100 pieces will be a hundredth. So you'll have 7 hundredths. And so this concept is really important to help your students understand before you start doing 100 grid problems. So let's start off with how you would solve a percentage problem where the part is missing. So if we have a car was purchased for $13,000 with a 20% down payment, and we want to figure out how much the down payment was, the $13,000 is the total amount of the car, or the whole. The 20% is obviously the percent, and the down payment is the part we're trying to find. So the way we're going to think about this is we're going to say, well, the whole is $13,000. That's the whole cost of the car, and this is also 100%. So remember, when you're working with percentages, you can think about it as equivalent fractions, where you have the whole being equivalent to 100%, and then you have the part, which is the thing we're looking for, being equal to the percentage that you're talking about, which in this case would be 20%. So we have $13,000 that represents the entire 100 grid. And what that means is that each one of these little squares, if we take the 13,000 and we divide it by 100, that means each one of these little squares is $130. And this is why it was important to make sure your students understand how to divide by 100, because it makes the process of figuring out the value of these little squares much, much easier. And then we know that 20% was the down payment. And so 20% is going to be this portion of the 100 grid because that's 20 of the little squares. And to figure out how much the down payment was, we just need to figure out what 130 times 20 is because each one of these little squares is $130 and we have 20 of those little squares. And so 130 times 20, if we do 13 times 2, that should be 26. And then since it was actually 130 times 20, we can put two zeros on the end. And that tells us that the down payment was $2,600, which is a reasonable answer if the car cost was $13,000. So that's how you would solve a missing part problem with a 100 grid. If you're missing the whole, you would solve it slightly differently. So in this case, we have 90% of the senior class is going on a class trip. And if there are 162 seniors going on the trip, how many seniors are there? So in this case, we have 90%, so 90 out of 100. And the seniors that are going on the trip are 162. So we have 162 is equivalent to the 90%. And we want to figure out how many seniors there are total. So the way that we would solve this problem is we would say, okay, well, the 90% is this section right here. And we know that that section is 162 seniors. And so we want to figure out how much one of these little boxes is. So to do that, we're going to take 162 and divide that by 90. And I'm just going to do this on my calculator, but obviously with your students, you would probably want to help them practice their long division skills. And when I do 162 divided by 90, this gives me 1.8. And so that tells me that each one of these little squares represents 1.8 of a student. Which obviously you don't actually have decimals of students in real life, but this square is just helping us understand the percentages. And so each percent is equivalent to 1.8 students. And what we want to do is we want to figure out how many seniors there are altogether. And so to do this, we basically just say, okay, well, if each one of these squares is 1.8, then the total number of students is going to be 1.8 times 100 because there's 100 squares where each one's worth 1.8. And so when you multiply by 100, this is opposite of dividing by 100. So you just move the decimal over twice in the opposite direction, which tells us that there's 180 seniors total, which is a reasonable number because 90% of the seniors was 162. And so that's how you would solve a percentage problem where the whole is missing. And then the last type of problem is a missing percent problem. So on this one, we know that Susan scored 48 points on a 60-point test, and we want to figure out what percentage did she get correct. And so to solve a problem like this one, we can write out and then the last type of percentage problem that you can solve with 100 grids is a missing percent problem. So when you're missing a percent, you might have a problem like Susan scored 48 points on a 60-point test. What percentage did she get correct? So in this case, we know that the total number of points on the test was 60, and she got 48 of them correct. And we're trying to find out the standardized ratio that has a denominator of 100 that's equivalent to this. So we're trying to find the percentage. And we could say, okay, well, if 60 points is the entire amount on the test, then that means that each one of these little squares is going to be 60 divided by 100, which equals 0.6. So each one of these little squares represents zero point 0.6 of a point or 6/10ths of a point. And we want to know what percentage 48% is. So basically, we need to figure out how many squares it takes to add up to get up to 48. So what I would do is I would do it in groups of 10 because I would say, okay, well, if I have 10 of these squares where each little square is worth zero point 0.6 of a point, that means that 10 of them equals 6 points. So you'd have 6 points in that column, then you'd have 12 points when you add in this column, then you'd have 18 points, and the next one would be 24 points. Sorry, my numbers are kind of getting close together. And then if we add on another 10 of those squares, that would give us 30. And then you'd get 36 and 42. And we're getting kind of close to 48. And in this case, it looks like if we add 10 more, we get exactly 48 points. And so that shows us that the missing percentage is going to be 80% because you have 80 little squares that it takes to get up to 48 points. And sometimes you might need to count by single squares instead of groups of 10 squares. So, for example, if rather than scoring 48 points, she had scored 45 points, in that case, you would have said, okay, well, up to this point is 70%, and that gives us 42 points. And then you would say, well, if I add another 10% or another whole column, that gets me to 48, which is bigger than 45 points. So then you just count up individual squares and you'd say, well, this is zero point 0.6 plus another zero point 0.6 would be 1.2 points, plus another zero point 0.6 would be 1.8, plus another zero point 0.6 would be 2.4. And then if you add another zero point 0.6, that gives you 3 points. And 3 points more then the 42 points gets you to 45 points. And so in that case, 45 points on a 60-point test would be 70%. So sometimes you might need to do that. But in this case, the answer was that 48 points on a 60-point test would give you an 80% on the test. So that's how you solve percent problems with 100 grids. The main idea is that you need to figure out the value of a single square and then use that to figure out whatever the question is asking for. So if you have any questions, let me know, and I hope you guys have a great